Hello again. I'm going to call this lesson today the scrambled two-step equation lesson. We've been practicing solving two-step equations, and we tend to get in a rut where our problems always look the same, and then we just get in a habit of doing the same steps repeatedly. And if they ever switch the equation around or make the equation in a different, write it in a different way, we sometimes don't know what to do. And so these are some questions that have been coming up in class, and I want to address these. So I'm going to call this the scrambled two-step equations. They're still two-step equations, but they're not written maybe how we see them a lot of times. So let's talk about these today. So here I have 15 minus 2x equals 29. In class, we talked about, well, the inverse operation of subtraction is addition. So I keep getting 8th graders and 7th graders that want to make the first step be addition. Well, let's talk about this problem. This minus sign right here belongs to this term, belongs to the 2x term. This 15 is actually a positive 15. There's no negative sign in front of this term, so this is a positive 15. We want to get rid of the 15 first. So since that's a positive 15, we actually need to subtract 15. And again, whatever you do to one side, you must do to the other side. So if I subtract 15 from this side, then I'm going to subtract 15 from this side. So on this side now, I have 14. I'm going to bring my equal sign straight down. Some of you get sloppy with your equal sign or lose your equal sign completely. Bring your equal sign straight down. And now over here, I still have a negative 2x. A lot of us want to just forget about that negative sign or that minus sign. That sign belongs to that term, okay? So this is a negative 2x negative 2 times x is supposed to equal 14. So we do our last step by dividing by negative 2, divide by negative 2, and x equals negative 7. Take care of that negative sign. It keeps getting lost in our work, and so you don't just lose it, it's always there. If it started there, it's still there, okay? Let's look at another one. 6 equals 18 minus 3x. Okay, so a lot of us are looking at this problem and you see that minus sign, so you immediately think your first job should be to add. Well, that's not true. That minus sign belongs to this 3x term. The term that we're first trying to get rid of is the 18. And the 18 is actually a positive 18. So to get rid of that, we actually need to subtract 18 for our first step. If we subtract 18 from the right side, well then we need to subtract 18 from the left side. 6 minus 18 is negative 12. I bring my equal sign straight down. I don't lose it. I don't stick it somewhere weird. My equal sign just comes straight down. And now my 18s are gone, and so what do I have over here? I still have a negative 3x. This sign is still here. It doesn't just go away. It's still there. It belongs to that term. Okay, so now my last step, the one-step algebra problem, divide by negative 3, divide by negative 3. Again, I bring my equal sign straight down, and negative 12 divided by negative 3 is a positive 4. So I find that x equals positive 4. Now we don't always check like we should, because I know it's kind of tedious, but we think x is the solution to this equation. Solution means it's the number that makes the equation be true. So I plug this 4. I could check my work and go plug the 4 in. 3 times 4 would be 12, and 18 minus 12 is 6. So I know that I got it right, okay? All right, some other ones that have popped up that we've kind of been having questions about. Negative x plus 7 equals 18. Well, we're not having any problems with our first step. We realize that our first step would be to get rid of this term, and since that's a positive 7, we should be subtracting 7. And if I subtract 7 from the left, then I should subtract 7 from the right. My 7s are gone. So now on this side, I still have a negative x. And on this side now I have 11. Well, we haven't known how to handle this negative here because there's not a coefficient, there's not a number there. Well, there is a number, it's just not written. That number that's there is a 1. We don't write 1 as a coefficient like we've talked about in class. So if you just see a negative x, well, that's like a negative 1x. They just don't put the 1. So that's actually a negative 1, and so now I can just divide by negative 1, divide by negative 1, and x equals negative 11. So if I were to plug this back into the equation to see if I'm right, this would be a negative 11, because there was a minus sign already here, or a negative sign already here, and then x is a negative 11, plus 7 is supposed to equal 18. Well, when you see this minus a negative, that's like one of those plus problems. Hey, that's a plus, and so now I just have 11 plus 7, and yes, that is 18. Okay, let's try another one. Okay. This is 14 equals 12 minus x. Well, we need to get rid of the 12 first. So I look at this term and I decide, is this a positive term or a negative term? Well, the sign in front of it doesn't indicate that it's a negative term. So that means I'm going to have to subtract 12 to make it go away. Okay, it was a positive 12. To get it to 0, I'm going to subtract 12. If I subtract 12 from the right, then I need to subtract 12 from the left. So now I'm at 2 equals, and over here I still have a negative x. That negative sign doesn't just go away, it's still there. Well, there's not a number here, so how do I handle that? Well, there is a number, we just don't always write it. It's a negative 1. So now you divide by negative 1, divide by negative 1. 2 divided by negative 1 is negative 2. Okay, and here's another one, a weird one. We haven't really seen any of these, and I wanted to talk about them today while we're talking about all these kind of weird two-step equations. This is kind of like a fraction, x minus 1 all divided by 4. Our first step is going to be to get rid of this denominator, and to get rid of that denominator, we're going to multiply by 4 over 1. And when I do that, my 4's cancel, so I'm left with x minus 1. If I multiply by 4 on the left, then I need to multiply by 4 on the right, and 2 times 4 is 8. Now I just have a one-step equation left, x minus 1 equals 8. To finish isolating the variable, we're going to add 1, and we get x equals 9. This would be an easy one to check real quick. I can plug a 9 back in for x. 9 minus 1 is 8. 8 divided by 4 is 2. So that is correct. Okay, last one I want to talk about today, and we've been talking about distributive property, and we've practiced it, and sometimes we see it written weird, where we're used to seeing the 5 on this side, and now the 5 is on this side. Well, it's still the same distributive property that we've been practicing, it's just that our arrows will probably go this way that we're used to drawing. So now when I distribute that 5 over the parentheses, now my equation is 5x minus 10 equals negative 35. Now this is a normal two-step problem that we're used to seeing. So I add 10, this is gone, so I've got 5x equals negative 25. 5 times x, the inverse property of multiplication is division, so I'm going to divide by 5. My 5's cancel, so I have x all by itself, which is what I was trying to do. Divide by 5 on this side, negative 25 divided by 5 is negative 5. I can plug that in real quickly, that's not a hard one to plug in. I plug in a negative 5. Negative 5 take away 2 is negative 7. And negative 7 times 5 is negative 35. All right, be careful with those negative signs and keep practicing. We'll see you next time.